So I think now it's time. We're almost done. We're almost to the end, but we're actually going to bring Ali on. He's our building science expert here at ROCKWOOL. And again, this is a report that's something that you guys all have access to just by, anybody on here is going to get an email directly from myself with other contacts, and you'll actually be able to, get these reports made for you. I know I just gave Ali a lot of work.
So this is one of our typical building science reports. Before I jump into the report itself, like we focus on two main things, is accuracy and transparency in our reports. So accuracy comes when we pick the source of our products, the source of our materials. We always try to use well-known trusted source for our analysis. For example, we use ASHRAE fundamentals, we use ASHRAE 90.1, and we try to use the properties of the materials in our analysis based on if the manufacturer has any published properties of their materials. We will try to incorporate that in our analysis to keep it as accurate as possible. And we want it to be transparent, is to list every single thing that we use in our analysis. For example, thermal conductivities, the source of our materials, the way we model it, if we made any assumptions, if we disregard one of the layers because it has no impact on the performance, we will list all of that in our report. So these are the main points that we always try to provide to our customers. So this is one of the reports that we run for Chris for his projects. So as you can see, the beginning of the report is self-explanatory, so I won't jump into that. But this report has two sections. The first section is the thermal analysis. So when we do the thermal analysis, for example, if you can see in this section, we listed what is the targeted R value. So Chris, he indicated to us that the target value, R value for the walls needs to be around 31, and for the roof is 60. And if that's not indicated to us, some other reports, the architects or the builder will indicate to us, I want to meet, for example, IECC 2015. So we will look based on the climate zone, and we will try to provide analysis for the specific climate zone. But in this case, we didn't put the requirement for that city because it was indicated to us what is the U value required or the R value required. And if you scroll down a little bit, then we start listing, we start with the name of our software that we use in the analysis. We always use softwares that's benchmarked and validated in the analysis. So to give an estimate or the prediction could be as close as possible to reality. That's one of the major goals that we want to do. And also, if you scroll down a little bit, then we start listing down the materials that we use in the analysis. So for example, as you can see, this is the thermal conductivity of each material used in this analysis. And we write below it the source of these materials. There's a little paragraph that indicate where did we get these U values, because the conductivity of materials varies a lot based on the source and also manufacturer. But we try to make, if we don't have a specific data from a manufacturer, then we will go to ASHRAE and use their tested values in our analysis. If you scroll down a little bit more, then we will list in this section, we will list the assembly based on these assemblies were designed based on for sure the design that was provided to us by Chris. So we list each material and the thickness, and also if we have comments on how these materials are attached. For example, we have the fiber cement siding, then we have an air cavity, but behind that air cavity, we will state that it is between the wood strapping and the spacing of the wood strapping. So we list these points because, for example, if the strapping was in a different spacing, that means our fasteners will have different spacing, and that will affect the thermal performance of the assembly. That's why we want to be transparent, showing what is our assumptions to give an idea to the builder or the architect what our assumptions and how can they achieve that thermal performance that we indicate in our reports. So if you scroll down a little bit more, after we list out our assemblies, we started putting our assumptions. For example, if we made, as I mentioned earlier, as part of to be transparent, we will just list down all the materials we use and what are our assumptions. So this section, it is very important. If you receive one of our reports, I really encourage everyone to read the part where we put our assumptions and our delimitation. In many cases, we do some assumption based on the current or what we have in hand or what we see on the drawings. But after we send the report, the architect or the builder will come back to us and say, so, oh, sorry, I forgot to mention that the spacing is not what you use in your analysis. Could you adjust that? So it's a good idea to go through our assumptions and come back to us for changes if the assumptions doesn't meet the actual design. So if you scroll down a little bit more to then after the assumptions, we have the results section where we state what is the, and this is the table that shows our nominal R value. So the nominal R value, which is the thermal resistance of the layers that makes up the wall, without taking into account the thermal bridging that Dan was talking earlier about. And then next to it, you will have your effective thermal value, which is taken in account the thermal bridging cost, for example, in this report, caused by the studs and the fasteners. And just to make something clear here, that Chris required an effective R value of above 30. So you can see the nominal is a bit higher, but for sure, like when you take in account the effect of the studs and the fasteners, then you will have a lower value. And we indicate on the right the percentage of reduction cause of the thermal bridging. So this is the end of the first section, which is the thermal analysis. Then we go to the second section, which is the moisture analysis, and also what we call hydrothermal analysis. Hydrothermal analysis is a great tool to use, especially when dealing with when you deal with assemblies that are different from what you see in the code, or you want to do some changes, or you want to consider using different thicknesses of materials or insulation. It's a great idea to consider hydrothermal analysis just for to validate the moisture drive in your assemblies and make sure that all the changes or the thickness of the interior insulation is not going to lead to some serious problems, especially when it comes to moisture. And it's kind of recommended when you do renovation. For example, in this house, one of the main problems, they just added insulation and they didn't consider other. It used to perform well, didn't have probably rot or any mold in the beginning, but once they introduced the insulation, one of the issues they did is that they reduces the heat loss, and the heat loss used to make the siding always dry because of the heat transmitted from the inside of the house to the exterior. But once you introduce insulation, that will significantly reduce the heat loss through the walls, and that will cause to build up moisture, and that will also lead to mold growth. So could you scroll down a little bit, Dan?
Oh, I gave you control. Sure. You want to go down to the graph?
Okay. So yeah, in our moisture analysis, something we do something similar. We list out all the assemblies. For example, in this report, we did not include the hydrothermal analysis of the wall assemblies because it doesn't need, it's a perfect wall. All the insulation was installed on the exterior. So we didn't have any concern about that. And also when it comes to the roof, it was well designed, and the amount of exterior insulation, as you can see, there is like, in this report, I can see like there's 7 inches of comfort board on the exterior side of the roof deck. Then below the roof deck, we have an R30 38 batt between the joists. So similarly, we list down all the assumptions, all the inputs in our model. We use WUFI for 6.5 in our analysis. It is one of the best software that you use in this field. It's well validated and we can trust the result. But one of the difficulties of using WUFI is what to put in your software. So it's very important to know how to enter these select materials and how to assemble these assemblies. If you scroll down a little bit to the criteria, sorry, I'm taking it like we're up to 5 now, but I'll just make it quick now. So if we look at it, once we run our analysis, we want to make sure that we meet some of the criteria that was defined by ASHRAE 160. And the main reason for that is we want to see that if our assemblies are performance are expected. So the first graph shows the total water content of our assemblies. In this graph, we want to see that the water content is stabilized over time. We run our analysis for 3 years. In some cases, we run it for 5 years. Even in some assembly, we go up to 10 years, depends on the assembly. For example, here we have it for 3 years, and we can see after the first year, the assembly started to, the performance started to repeat itself, and that's what we want to see. We don't want to see any increase of water content over time. That means there's a built-up moisture issue, and that needs to be fixed for sure. Then since once we validate that the water content is not increasing, then we start looking at the water content of the sheathing. So if you scroll down in this assembly, I believe it's using the OSB, as they mentioned earlier. So we kind of put a threshold around 16% of the OSB weight to be our threshold. So we want to see that the water content in the OSB layer does not surpass the 16% of its weight as water, and this is very important because if it surpassed that for a significant period of time, that means that could lead to some moisture issues such as degradation of our OSB sheathing. If we're using plywood sheathing, then the threshold will be a little bit different. And the next graph will show us the relative humidity level and the temperature at the sheathing, the interior side of the sheathing. And this could tell us a lot. One of the major things we look here is the potential risk for condensation. If we have the relative humidity, which is the green line, high for a very significant period of time, let's say above 80 or 90 or closer to 100, then we start investigating for condensation. If it's below 80, then we are much more comfortable. Also, there is a relation between the level of relative humidity and temperature, and that will, and we use these indications to check for mold growth. As you can see, there is a black line below, say mold growth performance criteria, and on the level of 80, if there is any risk of moisture mold growth, then we will have black dots, and the black dots will appear when we meet the criteria of the mold growth. Mold growth criteria is a little bit tricky. It's not straightforward. Doesn't mean when your humidity is above 80, that means you will have mold growth. You need to have relative humidity above 80 for a period of 30 days on average. The running average for 30 days should be more than 80%, and also the temperature of the surface needs to be between 40 and 40 Fahrenheit and between 48 to 104. So if you stay in between that and you don't have any issues for mold, that's also something we will specify in our reports.
Thank you, Ali. That was a great run through of the report. I mean, it's really, I think the big takeaway is if you guys have something that you want us to really go through, and Ali, I know, loves doing all these reports. He does about 3,000 of them a day, so he's really, really thorough at them. And you know, the big thing, and actually, if you, I wanted to bring back the black part of the mold growth. That's something, if you were on the last webinar, we actually showed a failing system up in Minnesota, and it was basically a trap system with vapor barriers on both sides of the wall system. So Ollie, again, he put that one together, but again, that's something that does not come off pretty. It's not going to even be, the insulation would be a lot worse if it was a mold supporting product in that wall. So thank you, Ollie.